A Russian soldier is stationed inside a trench deep inside the Ukrainian region of Donetsk. Around him are more soldiers, all waiting for the command to storm the final mile stretch towards the next town. The battlefield is silent, except for the whir of small propellers overhead, like the sound of a small mosquito. Ukraine has started its counteroffensive. Seconds tick past agonizingly slowly as the soldier tries not to move, otherwise the drone's detection systems might pick them up and make him a prime target. The world, just like the soldier, stands still in those few moments as the whir moves back and forth, and then there's a boom. The soldier is alive, but the soldiers in the next trench weren't so lucky. The whirl of propellers grows distant as the drone retreats to be outfitted with another mine. You see, the Russian soldiers are not being bombed by long-range missiles or artillery. Instead, mines are being dropped on them by small drones, and ironically, the mines come from Russia itself. The Ukrainian military has made significant advancements in the way modern warfare is waged, and not by inventing new or more powerful weapons, but by repurposing old ones. In this case, the trick lies in using reliable and plentiful anti-tank mines not defensively, but offensively. The mine in question, the TM62, a Soviet-era anti-tank mine designed to be as simple and effective as possible. Weighing in at around 21 pounds, the TM62 contains around 17 pounds of explosive, usually TNT. It looks like a classic cartoon mine, a flat metal disc with a fuse on top. There are several different fuse types commonly used with the TM62, with the traditional pressure fuse being the most popular. Typically, the TM62s will be laid down by engineers and dug slightly into the ground, or deployed via a GMZ mine-laying vehicle to speed up the process. There's even a mine-laying helicopter that can cover huge swathes of ground with mines. But while the Ukrainians are also deploying the TM62 from the air with drones, the delivery method is quite different. In fact, it's another excellent example of Ukrainian wartime ingenuity. Rather than using traditional launchers and long-range artillery, Ukraine has started using drones as its primary ordnance delivery method, particularly as an anti-infantry and anti-tank tactic. Drone warfare isn't a particularly novel concept. It was first proposed all the way back in World War I, when both the US and the UK independently started development of the first military drones. But the first attempts were only partially successful. Early drones were no more than what would today be called glide bombs, explosives packed into a shell and put into a slightly more aerodynamic container that would either fly independently or be dropped from an airplane. These flying bombs were bulky and not particularly precise, which made them suboptimal, especially when deployed above Allied troops en route to the enemy. The chances of these bombs taking a sharp turn downwards and causing devastating losses from friendly fire was too great to ignore. As a result, drone development remained largely theoretical for the next several decades. The drone that you might be more familiar with is the American design that was used to great effect at the turn of the 21st century, particularly in the War on Terror. One of the hallmark models was the General Atomics MQ-9 Reaper, a remotely operated unmanned aerial vehicle or UAV in pretty much every sense. The drone looks more like a miniature airplane and has the ability to hold and deploy multiple missiles or bombs from its wing carriages. The drone's success in Afghanistan was mainly due to the enemy's lack of anti-air defenses and detection capabilities. This allowed the drones to fly pretty much unimpeded through enemy airspace and deliver their payloads effectively. But the war in Ukraine is being fought on a very different scale and thus requires a different type of drone. Enter the DJI Mavic, a series of commercial drones from China. These drones weren't designed for industry or wartime. They were meant to be simple and cost-effective cameras in the sky, with the ability to live stream a video feed to an accompanying device. They were designed for commercial purposes, to take photos and shoot videos for parties or advertisements. However, it quickly became clear that these small drones could be veritable powerhouses on the battlefield in Ukraine. These small quadcopter drones could be used to gather valuable information on enemy movements and formations. This is due to their being relatively silent, particularly compared to large aircraft or land vehicles. They're also maneuverable and, perhaps most importantly, cheap and abundant. Even some of the most sophisticated DJI Mavic models generally cost less than $2,000. This is an outrageously low price for military-grade equipment, especially considering the drone's versatility. So the Ukrainians started using the drone for more than just gathering intel, and that's how we arrived at the situation today, where drones are dropping anti-tank mines or grenades behind enemy lines. The construction of this deadly mechanism is relatively simple. It starts with the basic quadcopter drone, which is outfitted with a grappling system, typically custom-made or 3D printed to be as light as possible. The grappling system is designed to be released remotely by the drone operator, dropping its payload when the drone hovers over the target, Alternatively, the drone is outfitted with a latch that unhooks to release the ordnance when needed. A larger drone can also fit a tray made from a grill, such as those found in ovens, taped or strapped to the drone on one side and latched to the other. The mines lay flat on the grill. When the operator is ready to deploy the mine, they send a signal to unlatch the grill from the drone. In theory, the mine could fall flat onto the ground, provided that it's been dropped from a low height. But the DJI Mavic is a relatively small drone, incapable of hauling dozens of pounds of equipment, like an anti-tank mine. For this purpose, the Ukrainians have started domestic drone production using imported resources. The most common drone of this type is the so-called Vampire or Baba Yaga. This drone is based on another DJI design, the agricultural Agras T-line. Agras is a series of larger quadcopter drones, with the most recent models capable of carrying farming and fertilizing equipment weighing as much as 110 pounds. But considering the scale of the ordnance that Ukraine is working with, slightly older designs that can carry 50 to 100 pounds of equipment are perfectly suitable. The Ukrainians have adapted the base Agras chassis, or reverse-engineered the drones to fit 6 or 8 propellers. To improve their operational range to a couple of dozen miles, the Ukrainian drone designs add extra battery packs to the side of the drone and attach extra antennas to boost the drone's signal and allow multiple drones to combine their signals and data streams. The added gear has made the heavy drones slower and much less maneuverable than the base DJI Mavic. It also reduces the drone's maximum payload, with some specifications suggesting a limit of roughly 40 pounds. However, these drones can now carry modified TM62 mines or a host of other ordnance, such as grenades, mortar shells, or repurposed parts of anti-tank missiles. Additionally, the costs of making these drones are still significantly lower than dedicated seek and destroy military drones like the aforementioned MQ-9 Reaper. Plus, these drones have a vastly improved operational ceiling, able to hover at an altitude of 1,300 feet. So that's the drone covered. But what about the mine itself? Based on different images and videos circulating on social media, there are a few different mine designs in active use. Initial images showed mines with minimal modifications being held by drones, intending to be delivered directly onto the target. This is the most basic solution, but it's not that effective, as the mine's inertia and considerable weight can cause it to steer off target, especially if the drone is being deployed high above the ground. So the Ukrainians started modifying the mines. The most common modification adds a tail, so to speak, to one end of the mine in order to stabilize it. Typically, the tail is made from a PVC pipe with a piece of sawed-off plastic bottle at the end to mimic fans. This tail stabilizer causes the mine to fall roughly straight down and orient itself so that the modified fuse is typically the part that hits the ground first. The mine's fuse, which is traditionally a pressure plate designed to set off the mine at weights of between 330 and 1,100 pounds, can be replaced with an assortment of different fuses. For the drone's purposes, the most effective fuse detects changes in air pressure or impact, which detonate the mine when it reaches the ground. Alternatively, some videos indicate that these fuses have been replaced with traditional detonation fuses. This is supported by the fact that mines appear to have smoke rising from them as they fall, indicating that the fuse has been lit long before impact. This range of modifications, combined with multiple drone delivery systems, has allowed Ukraine to constantly stay one step ahead of Russia. If one type of system seems to have been solved by the enemy, the next drone can use a different fuse to change up the tactics and cause more confusion. This has been noted to be a particularly effective strategy in the ongoing war, in part because the Russian military has a stricter order and command structure than Ukraine's. Most Western strategists also consider the Russian military lacking in the ability to adapt to more nuanced, modern, or improved tactics. This is in sharp contrast to the Ukrainian military, which has been trained primarily by Western forces since the annexation of Crimea in 2014, which is considered to be one of the starting points of the ongoing conflict. Of course, the drones carrying mines aren't infallible. As mentioned, one of the main reasons the American drones had so much success in Iraq and Afghanistan was because the local insurgents didn't have meaningful anti-air defenses and detection capabilities. In Ukraine, the situation is practically reversed. Russia is widely considered to have some of the most sophisticated anti-air defense systems in the world, perhaps even matching those in the US for national defense purposes. Throughout the war in Ukraine, both sides of the conflict have contested the skies by means of relentless aerial attacks. To boot, the Russians are also well aware of the kinds of drone tactics that Ukraine can use, as the DJI Mavic and its close cousins, the agricultural drones, are imported from China into Russia too. Additionally, China has been Russia's closest ally throughout the conflict, with some reports suggesting China has been selling weapons and technology to Russia despite sanctions from the West, albeit without any concrete evidence having been produced to substantiate the claims. Thus, Russia has implemented robust anti-drone tactics itself, including detectors, jammers, and anti-air guns capable of detecting and shooting down drones before they can reach their target. Additionally, the constant seesaw of the front line in Donetsk makes operations near active combat much riskier for the Ukrainians due to their lower overall numbers. This means that drone operator squads have to deploy their drones farther away from the front, adding to the travel time and distance that the drones must cover before they can release their payloads. The battery packs that are added to domestic Vampire drones can compensate for the extra distance, but the combined weight of the drone and the mine it's carrying quickly nullifies the effect. It's estimated that for every drone that Russia shoots down, around 8 Ukrainian drones fail to reach their targets simply due to their batteries running dry. Still, the drones that do manage to reach Russian positions can have a devastating effect, particularly due to the sheer range of ordnance that Ukraine can use with them. In essence, the drone war in Ukraine is based on the cost-to-effect ratio. In particular, drones carrying anti-tank mines are typically used to destroy enemy armored vehicles or other specialized equipment. The drones are designed to be as cheap as possible, unlike their targets. While the cost of anti-tank mines is now approaching tens of thousands of dollars per unit, they are available by the truckload in Ukraine. On the other hand, a Russian tank can cost millions of dollars and much longer to produce. In fact, it could be argued that the advancements in drone warfare have directly caused Russia to abandon the prospects of developing its next-generation tank. The T-90M was supposed to be replaced with the T-14 Armata that had more offensive and defensive capabilities and integrated electronic warfare systems. However, only a dozen or so of these tanks were produced before the war started. When Russia deployed the new tanks to Ukraine, the results were disappointing. The tanks didn't display much more survivability than the T-90s, making them even more expensive pieces of metal for Ukraine to target with comparatively dirt-cheap equipment. If a $1 million tank can be destroyed with a basic anti-tank mine dropped from a drone that costs Ukraine a small fraction of the price and takes just a couple of days to make, Russia's ability to fund the war could quickly start drying up. But there's another cost that became one of the main reasons Ukraine has continued using drones to carry mines and other ordnance: people. By using a drone that can be operated from a dozen miles away, the Ukrainians can strike enemy infantry positions without risking their own personnel. Considering that Ukraine has less than a third of Russia's total population and likely under half of Russia's active military personnel, soldiers dying for Ukraine is much more costly than for Russia. The versatility provided by using modified drones and mines in this way goes beyond taking out enemy infantry. In fact, the mine doesn't even necessarily need to detonate upon impact. With some additional modifications to the stabilizer, the mine should be capable of falling from a relatively small height onto the ground, where it can stay dormant until an enemy vehicle drives over it. This method of mine delivery enables the Ukrainians to deploy mines in areas that traditional mine-laying squads can't reach, behind enemy lines. This has created a back-and-forth mine-based form of warfare in Donetsk. When the Russian military moves forward with its tanks and armored vehicles, it needs to clear a path through suspected minefields. No sooner has it done so, the Ukrainian military remines the same area with a fresh batch of mines, typically from the air. So the next time a new Russian convoy arrives or repositions itself in the area, there's a new supply of mines in place to cause mayhem for them once again. Using mines on a convoy of vehicles is particularly effective, as taking out the lead vehicle leaves its shell on the road, blocking the path for the rest of the convoy. The other vehicles are forced to reroute or retreat, with both options leaving them vulnerable to more mines. Moreover, the manual labor involved in trying to move the destroyed vehicle out of the way is typically not worth the time or danger, as the soldiers are sitting ducks for long-range strikes from Ukrainian forces. The TM62 mines are not only being deployed via drone either. Their ubiquity in the current war has led them to become one of the most common ordnances used in Ukraine. For example, a TM62 has more than enough explosive power to destroy an enemy fortification or collapse a building. When combined with a time-delayed fuse, the mine turns into a satchel charge that can be deployed by infantry when needed. All a soldier needs to do is get close to the enemy position, light the fuse, toss the mine, and get clear of the ensuing explosion ASAP. Videos circulating on Telegram show multiple cases of troops using the TM62 in this way. The main targets in the videos so far seem to be trenches and buildings, where they're used to destroy fortified positions or kill the enemy infantry stationed in them. However, it should be noted that when anti-tank mines are used in this way, whether by drone or as a satchel charge, the targets are usually not tanks, ironically. This is due to the fact that even the larger Vampire drone is able to carry only a single mine. If the drone targets a vehicle and ends up missing, it doesn't have any more ordnance to drop. Mortar shells, on the other hand, typically weigh only a few pounds, and the Vampire drones can carry 3 or 4 of them at a time. Should a mortar shell miss the target, the drone can take a few minutes to reposition and then drop its other payload before flying off to evade the enemy's counterattack. Another reason for mines not being useful in some scenarios is their larger explosion radius. When used as a satchel charge, the mine creates a much larger explosion than traditional ordnance. If the fuse is set to a low timer, as some of the videos showing Russians using the tech indicate, there's a high risk that the operator will get caught by the blast or its after effects. For drone operations, this also means the drone has to fly at a height of at least several hundred feet above the target. The extra height greatly decreases the accuracy, but improves the drone's survivability. Against a moving target, however, the loss of accuracy can mean that the entire operation is a waste of time and money. Besides, the anti-tank mine is not even the best weapon to drop on tanks. This might seem counterintuitive, but it has to do with how Soviet tanks were designed. The T-line of the Soviet tanks, ending with the most recent T-90, all have heavily reinforced armor around and on top of the vehicle. When a drone drops an anti-tank mine, the mine's weight and inertia mean it's unlikely to hit the tank directly. While the explosive charge is potent, it might not be sufficient to destroy a tank if it strikes it indirectly. On the other hand, Russian tanks use an autoloader system for their main armaments. The system stores spare ammunition in a compartment below the main turret, keeping it away from the crew members. While this means that the tank can fire more rapidly and doesn't need a separate crew member to reload the tank, the compartment itself becomes a potential weak spot. Since it sits closer to the ground, an anti-tank mine detonated below the tank or a mortar shell dropping directly on the chassis below the turret can cause enough of a shockwave to detonate the tank's ammunition. Depending on how much ammunition the tank has left in the loader, the resulting explosion can completely obliterate the vehicle from the inside out. That's why the Ukrainians have used even smaller DJI Mavic drones with mortar shells to target tanks and vehicles specifically. This strategy shifts the cost-to-effect ratio even further in Ukraine's favor, since the small drones are much more readily available and can easily be replaced. In fact, there are estimates that Ukraine might be losing 10,000 drones per month, with roughly the same number in the air over Ukraine at any point during the war. This demonstrates how big an impact drones are making in modern warfare. Particularly since drones are much easier to replace than people, they're being used as both eyes in the sky and arms that drop bombs. But how do these drones locate their targets in the first place? The answer is, perhaps unsurprisingly, with even more drones. The Vampire drones don't have to be attack drones. Their improved antennas make them excellent signal boosters for short-range reconnaissance drones, a role that the DJI Mavics can readily fill if needed. Furthermore, Ukraine has its own industry producing long-range surveillance drones, the Skytons. Skyton Raybird 3 is a drone designed back in 2014 for intel and reconnaissance missions, and was adopted by Ukraine's armed forces shortly after. The Raybird 3 has an operational range of over 1,000 miles and is capable of flying for more than a day without needing to recharge. Furthermore, it only needs to be within 60 to 100 miles of a control center to receive active orders, meaning that it can fly about 60 miles behind enemy lines to scout for targets. The drone can also fly at altitudes of up to 11,500 feet, easily bypassing common anti-air defense systems, looking for drones closer to the ground. A photo appeared on Russian social media, showing a Raybird that had been felled near the Krasnodar region, which was around 130 miles behind the front line at the time the picture was taken. This indicates that the drone can feasibly operate even deeper into Russian territory. But the Raybird 3 is just one of the pieces that powers Ukraine's drone-based surveillance system, with real-time communications again reserved for the ever-present DJI Mavics. This system means that Ukraine can keep an eye on both current events on the front and incoming Russian supply lines to scout for potential targets. Once viable targets have been identified, the Vampires and smaller drones with grenades can be deployed to perform repeated drop-down attacks. The sheer scale of drone warfare in Ukraine creates disturbing implications for the future of modern conflict. Tens of thousands of drones working in tandem to create real-time coverage of practically the entire front line would mean that nobody on the battlefield is safe from death from above. Now consider that Ukraine started the war significantly on the back foot. The Raybird 3 is estimated to cost $450,000. That's a hefty sum, but pales in comparison with the famous MQ-9 Reaper, which has a price tag of over $30 million per unit. A country with a larger economy and military defense budget, like most NATO members, could easily replicate Ukraine's successful use of drones to create veritable drone armies. Drone operators could undergo years of training on simulations or even in real-life scenarios, making them much more common than in the Ukrainian and Russian armed forces currently. All of these factors combined could, and arguably should, inspire NATO members to rapidly modernize their military forces to include multiple kinds of drones. With drones at the helm of conducting offensive missions, the potential loss of lives of friendly troops is likely to be greatly minimized, and this could be the great equalizer in modern warfare. considering China has an active military force of 2.3 million troops, while the US has only 1.3 million soldiers. A larger supply of drones and more advanced military technology could more than compensate for the disadvantage in manpower. But for now, the world will watch on as drone warfare improves by the year in Ukraine. Maybe the Ukrainians are building an even better version of the vampire as we speak, ready to turn the tide of war once again. But what do you think? Will drones be able to save Ukraine in the war? And how will drone warfare impact the militaries of the future? Leave your comments below, and thank you for watching.